Welcome to the session on measures of central tendency and spread. Measures of spread. The objectives for this session are to calculate measures of spread such as range, interquartile range, and interpercentile range. A measure of spread is a measure of how spread out the data set is. Quartiles split the data into quarters. So if we have a look at the number line, then in a data set, this might be where the minimum is. And after 25% of the data has passed, we have quartile 1 or Q1. This is also known as the lower quartile and is a quarter of the way through the data. Another 25% on, and we have Q2, also known as the median. This is halfway through the data. It splits the data into two equal parts. And another 25% of the way along, we have Q3, or the upper quartile. The upper quartile is 3/4 of the way through the data. And finally, another 25% on, we have the maximum. The range is equal to the maximum minus the minimum. And the interquartile range is Q3 minus Q1, or the difference between the upper and the lower quartiles. Let's now have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We have the salaries of 20 employees in a company given on your screen. These are measured in pounds per month. Find the range and interquartile range for this data. The range is equal to the maximum minus the minimum. So 1,584 minus 110 to give 1,474. And now for the interquartile range. Remember that if there are n data values, Q1 is in the n over 4th position and Q3 is in the 3n over 4th position. Also remember that if it's not a nice neat whole number, then round up. And of course the interquartile range is Q3 minus Q1. So Q1 is in the 20 over 4th position, which is the 5th position. So Q1 equals 118. And Q3 is in the 3n over 4th position. So substituting 20 in place of n gives us 60 over 4, which is the 15th position. And so Q3 equals 468. Therefore, the interquartile range is 468, which is Q3, minus 118, which is Q1. And this is equal to 350. Now let's remind ourselves of percentiles. Percentiles, remember, split the data into 100 parts. So if we're looking at the number line, the minimum and maximum might be as shown. And 10% of the way along, we have the 10th percentile. This lies 1/10 of the way through the data. And for another example, 63% of the way along, we have the 63rd percentile. And the 63rd percentile lies 63% of the way through the data. 63% of the data is less than the 63rd percentile, and 27% of the data is greater than the 63rd percentile. And now for the interpercentile range. This is the difference between the values for two given percentiles. Usually these percentiles are the 10th and the 90th percentiles. Let's now take a look at an example. It's the same set of data, but this time we're required to find the interpercentile range using the 10th and 90th percentiles. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. The 10th percentile is in the 10n over 100 position, or 10 times 20 over 100. Notice, of course, that n equals 20. This is equal to 2. So the 10th percentile is in the second position. Therefore, the 10th percentile is equal to 111. And now for the 90th percentile. This is in the 90n over 100 position, or 90 times 20, because n equals 20, over 100. This is equal to the 18th position. So the 90th percentile is 555. Therefore, the interpercentile range is the 90th percentile, which is 555, minus the 10th percentile, which is 111. And this is equal to 444. This brings us to the end of this session. If you have understood its contents, you should be able to calculate measures of spread, such as range, interquartile range, and interpercentile range. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.